Okay, this is problem 16, and this is King Kong. Okay. Here's King Kong, and he's hanging on. King Kong. Here's an Empire State Building. Okay, and how long it took, calculate how long it took King Kong to fall straight down from the top of the 380-meter tall Empire State Building and its velocity just before contact. So, okay, so the ground is here, and we're going to say that that's 0 feet or meters, and the distance, the height that we was in or at, we're going to say that he was at 380. Okay, so this is the initial distance. Okay, so he started here, initial, and then when he fell, here's the final position. Okay, so you can use S as a position. Okay, and they want to know how long did it take. So they want to solve for S. So here is the S initial plus the velocity initial minus the acceleration t. Okay, so we said that this is the initial, so that goes here, and the initial velocity, in other words, when he started falling, he started from a standing position, or he didn't have any velocity, so this has to be 0. Okay, and then this is the final. Okay, so the final is this. So then we set this to 0. Sorry. And he started at the initial of 380 meters minus 9.8 squared. Okay, so then we solve for t, and since this is 0, we can bring this to the other side. 80 meters. Okay, and then we can divide by 2, so 4.9 meters squared t. Okay, so we solve for t squared, which is really 380 divided by 4.9 meters squared, square root of that. Okay, so there's no square root here, but the other way of doing it is by saying 380 divided by 4.9, close parentheses, raised to the 0.5, 8 seconds, 8.8, 8.806. And yep, got that right. Okay, so now they want to know the velocity. Okay, so let's do that. I believe you can take the derivative. So this is the distance formula. I'll say this is final, initial, and we'll call that G. So if we take the derivative, this when you take the derivative, it yields the velocity formula. So when you take the derivative, it's going to be that, and then this is a t goes away, and then this would be negative 2 G T2. So I believe it's going to be V final VI, and then this cancels, so it's negative G T squared. I believe this is correct. Let's see if we can test it. The initial velocity on this one was 0 because he was resting on top of the empire, and we already know what T is, so we should plug it in there, so we should be able to find the velocity. Okay, 9.8 meters per second squared, 8.806 seconds squared. And mind you that you're going to end up with a negative velocity. Negative velocity means that it's going in a downward direction. Okay, so 9.8 times 8.806 squared. Okay, 697. That sounds kind of big. Let's do that again. Oh, the T is not there because it factored, right? So then it's just that. Okay, I did a little error there. The T, it goes to this, once you bring it out, it goes to 1, so it's not squared. So that's the right equation. So all you do is 9.8 times 8.806, 86, 86.2, 86.2 0.29 meters per second. Yep, got the same. Okay, so let's try another one. Look at this here. Let's do copy. We're going to do 17. So we're going to go ahead and copy here. Okay. Okay, so he's probably in 17. Now in this case, it says a stone is thrown downward with a initial velocity of 8 meters per second from a height of 25 meters. Find the velocity with which it strikes and the time it takes to reach the ground. So when you have stuff like this, it's always good to make a picture. So let's pretend, in other words, for you to throw it, let's pretend that you're in a building or a cliff, and let's say that this is 25 meters from there to there, and you're here. Okay, in other words, let's start here. You're here, and you throw the rock in that direction. Okay, so this is 25 meters, and when you throw it downward, you throw it with the initial velocity -8, and since it's downward, you put a negative. If you had thrown it up, you put a positive. So meters per second from a height. Find the velocity at which it strikes and the time to reach the ground. Okay. So we can set this as 0 distance. So we can say that this is the initial, and then this is the final. And we can say that it's -25 meters because you're going downward. Okay. So then we can use I'm going to start using small letters. Final equals S initial plus velocity initial T minus G T squared divided by 2. Okay, so now we pretty much said, okay, this is the initial velocity that goes there, and we said that the initial distance, we're going to say that it's 0, that goes there, and this is the final velocity that goes there. So we're going to say -25 meters equals, and we said that this is 0 meters, so that's 0, so it does not contribute anything. Now it's a plus, but we have a -8 meters per second T minus 9. Let's go ahead and put the constant, gravitational constant. It's just 9.8 meters per second squared T. Okay, so now let's go ahead and set this as a quadratic equation. Basically, that's what this is going to be. Okay, so we're going to go ahead and set this to 0 and be 25 meters minus 8 meters per second t minus 4.9 meters squared. Okay, so you have a quadratic. So let me put this in a nicer form. So really you just want the coefficients, which is 8, 20. You can plug them into your TI solver. Let me get my TI solver since I don't want to use the quadratic equation. Okay. And if I put this second order, so we're going to say it's negative 4.9, negative 8, and positive. So you're going to have two answers. So we'll probably have to test. And the roots are s equals negative 3.21, but it's a negative number, and the other one is 1.58 seconds. So I would pick this as your answer, and let's see. Yep, there it is. Okay, that looks good. Okay, so now you have that. So now you want the velocity. Okay, and again we can say that this is, we start with the equation, S final equals S initial plus initial velocity minus g t squared. We take the derivative, and when you take the derivative, you're going to have v final equals, and this goes to 1, so this is initial, and then the 2 comes to the front, but there's a 2 here, and this goes to 1, so here's the equation that we're going to use. Okay, so they want to know the initial velocity or the final velocity. So we know that this velocity, the initial, is this here. So we're going to say negative 8 meters square second minus, oh, and there's g, 9.8 meters, and this is going to be 1.58 seconds. Okay. So 9.8 times 1.58, it's going to be negative 15.48, and we're going to add the 8, so you should end up with 23.5 meters per second. And let's see if it is. Yep, it is correct. Okay,